Hello and welcome back to Residency with Dr. Purnima. I hope that these short lectures are really helping you out in your residency. So let's dive into today's video. The forest plots look something like this. So this is the visual representation. Mainly it is seen in meta-analysis because it compares various studies. So you can see that there are four columns, 1, 2, 3 and 4. Okay, so these are three left columns and this is one right column. So it is comparing study 1, study 2, study 3. So various studies are being compared here. So first we will try to see individually what each of the column is trying to tell us. So first column is representing the name of the study and the author with the year. So suppose we are going to say a study, suppose XYZ study by any author ABC, published in the year 1998. So this is written here. Then in the second and third column, it is for the study group and the control group. So in the meta-analysis, we usually have studies which have two arms. These are generally RCTs, and therefore we have to take the result from the study group as well as the control group. So this is how each study will be categorized, and this column on the right hand side will represent the odds ratio. You can see here the odds ratio of the study is calculated. Now there are two lines. If you can see very properly here, this dark line, this dark solid line is actually the line of null effect, and besides that there is a very faint line. Okay, it might not be visible. There is a faint line, that is dashed vertical line, which will represent the overall meta-analyzed effect. So again, if we try to understand, if I clear all this and we try to understand it again, so this is the table used in meta-analysis, and forest plot has this column. First column is for the name of the study, author and the year. Then this is for the study group, this is for the control group. Here we have odds ratio. This one line, the solid line is for the null effect, and the dashed vertical line besides that is the overall meta-analyzed effect. So I hope that this is clear. Now we come to what further we can see here. Now you can see there are various horizontal lines. So this is a horizontal line, this is a horizontal line. So one long at the base, this one, represents a statistic line at linear or log scale representing standardized mean difference or odds ratio. And these multiple short lines, each horizontal line represents the result of individual studies with 95% confidence interval at both ends of horizontal line. So what do we mean by this? So this is the confidence interval, 95% confidence interval of the study, and the larger the line, the lesser effective is the study. You can see here the confidence interval is very large. That means that the study is less effective because the confidence interval is greater. We need a very short confidence interval. So suppose there are two graphs like this. One is, this is square, one is like this and other is like this. So we will say that this study is more effective because the confidence interval is lesser. So we want a lesser confidence interval as compared to this line. So this is the horizontal lines. So then we come to these boxes. Now you can see this is a square, this is another square, this is third square, and this is a diamond. So the square represents study of each, the weight of each study. That is, if suppose this is one square and this is another square. What is the difference? The difference is in the size of the square. So size will represent the weight of the study, how effective the study is. So if the box is larger, there is more sample size in the study and therefore the weight of the study is more. If the box is smaller, that means there is less sample size and the weight of the study is less. And this diamond is actually the meta-analyzed weight, that is the summary of the weight of all of the studies, which way it is pointing, that is here. So now if we try to understand and integrate all that we have learned, so here we can see that this study one has a higher box. That means it has more sample size, and as compared to this and this, it also has a lower confidence interval, and it is favoring the intervention. So what we have written here, that if it goes towards the left, it is favoring intervention. If it goes towards the right, it is favoring control. But again, there is one caveat, that if the confidence interval line crosses this vertical midline, then the study is not shown to be significant. Now suppose I have another study which is like this. So this means that the confidence interval is short, the sample size is more, and it is completely in the territory of the favoring intervention and not crossing this midline. So this is considered as a significant study. That is, it is significantly, statistically significantly favoring the intervention. So whenever you are studying the paper or you are looking at the journals, then you should try and analyze this for yourself. Then you will be able to get into the habit of learning it. Now, if you have one like this here, that means this study is favoring the control group. That is, it is the intervention is not very effective. So this is how we try to interpolate and get to know the information from this one single plot, forest plot, which is very, very effective in telling us a summary of the data. So if you found this video helpful, then do like, share and subscribe to this and share it with your co-PG, because this is a snippet taken from our Radonc Residency app, which is a lecture series covering all the important topics from clinical oncology, general oncology, radiobiology, radiation physics, medical statistics, and everything that you require for your radiation oncology residency. So please check that app out. All the details are given in the description below. Download the app and see the lectures for yourself. I'm sure it will be of great value to you. And if you found this useful, then please check out our next video and it will give you value too.